All right, so we learned how to calculate the equilibrium constant, but I want to kind of just go over what the constant means and how we can use that to tell what's happening with an equation. Okay, so on page 488, I'm just going to go over what's in the pink boxes. And so you just need to write this down and just study what it means. I like the visual of it on page 489 as well. So what this is saying is when the equilibrium constant is large, so I'm gonna write a big K, okay? When it's large, okay, then that means it makes, okay, makes lots of products. Okay, makes lots of products. So when the equilibrium constant is large, then it really moves. It favors forward direction. Favors forward reaction. Okay. And then what that also tells us is that at equilibrium, the larger the equilibrium constant, that at equilibrium, there are more products. And so it would be at equilibrium, more products than reactants. More products than reactants. Now, obviously the reverse to that would be when the equilibrium reaction is small, it favors the reverse. Favors reverse. So there would be more reactants at equilibrium. All right. So those two should make sense. And like I said, I like the scale pictures on page 489 as well. That kind of tells that. So we learned how to calculate it, but we need to know what to do with the information that we can calculate. Okay. So when we calculate it, if it's a larger number, it's going to favor the forward reaction. It's going to favor producing the products. Okay. If it's a smaller equilibrium constant, then it's gonna favor more the reverse reaction, and there are going to be more reactants at equilibrium than products. Okay, now if K equals 1, okay, if K equals 1, then it is at equilibrium. Okay, that means that it's at equilibrium. All right. So those are the three ways that we can evaluate what a reaction is doing based on the equilibrium constant. So again, when the constant is big, it favors the forward reaction, and you're going to have more products than reactants at equilibrium. When the equilibrium constant is small, it favors the reverse reaction, and there are going to be more reactants at equilibrium. And when K equals 1, then what that means is the concentrations of both are equal. The rate is equal going both directions. All right, and so you're at equilibrium when K equals 1. Okay, now let's go over. Well, let's just go over example 16.2 on page 489. Okay, it says the following reaction has an equilibrium constant. And you guys can read this, so I don't need to write it on my whiteboard. Okay, so we have the equilibrium constant. If we have K equals 1.4 times 10 to the negative 25th molar at 25 degrees Celsius. All right. So the question is, how can this be written as a one-way reaction? All right. So if we have 10 to the minus 25th, then that means we're at there are 25 little zeros here before we get to our numbers, right? I'm not going to write 25 zeros. Okay. So what that tells us is K is pretty small here, right? If K is pretty small, we have our reaction that they originally gave us that I should have written. We have 2 and That makes 2SO2. Oh, I'm sorry, this was 3. Okay, plus O2. All right. Okay, so it's saying if we have an equilibrium, if we have an equilibrium constant of that for this reaction, all right, that's going both ways. If it is that small, all right, then it basically is saying that even though this is technically an equilibrium reaction, it really is only going to go in one direction. If it's this small, then the only direction we're going to be doing is the reverse. Okay, and so what you can do is bring it down, and you can flip it around and say 2SO2 plus O2 will yield 2SO3. Okay, that for all intents and purposes is going to be that reaction. All right, so when you have an equilibrium constant that's that small, it's saying it's not even going in that direction. The only way that this is happening is actually the products are reacting to make the reactant in the way that this is written. Okay, and so the question was, what is the one-way reaction that you can write based on this? And it would be the reverse reaction because it is so small. All right. And so I'm going to have you can do the comprehension check number 3 on your own. You don't need to send that to me. I just want you to work on that to give you some practice. All right. So I'm going to end this video here.